Okay, we are doing 23, 20023. Instead of writing May and June, I just put June, J for June. And then paper variant 11 and 21. Okay, do you want me to go over question by question?
Yep.
Okay, we
Can we
go.
start with paper two?
Say again.
Can we start with paper two?
Start with paper one now.
Paper one I didn't do. I only did paper two.
Then how are you going to? We don't have time to waste lah. Ask you to do, you must
Uh,
do your homework. Okay lah, we start with paper one lah because if you don't have time to, you can do it
okay.
lah. Can do it now lah, as we go
Yeah.
along. Have you got the paper?
Uh, not a best SI base unit C.
Which unit is not an SI unit? C, okay.
C.
What is the best estimate for the number of atoms in a piece of metal of volume 50 cm cube?
B.
This one got various ways. I can either take diameter as 10 to the power minus 10 meter and then work from there. Or you can work with density of copper, just a rough estimate only. It may be wrong, but that's roughly it is. And density is mass or volume, n nm over v. Then n is cross multiply m there. Right? Density of copper is 7.5. Volume is 50. Mass 64 for copper. And then this one is atomic mass unit in cm. So it's
Yeah, boy.
about B. Okay. This is
Yep.
estimate only lah. This may be wrong, but roughly that is the value. Right? As I say, if you find this is difficult, use your will. Take the diameter as 10 to the power minus 10, and then work from there.
Okay.
How about this one?
This one is boy.
What do you think? What is your answer?
Accurate, but not precise.
Accurate means it's near to this value.
Oh, serious? Oh, I thought it was the other way around.
No, accurate
Okay,
means
then precise but not accurate.
precise means they are close together to each other.
Oh, okay.
Right? The answer is D. Precise as the reading are close to each other, not accurate as a mean diameter. Mean is about 48 or 47, doesn't matter. And it's very far away. Okay, how about this one? Magnitude resultant force.
C.
Right? Complete a parallelogram. It's a rhombus. That's the resultant. And this is 10. So this must be 10. So these two sides are equal, 10. So this one is 60. This is also 60. Right? This one, these two add up must be 180. So this is 60. These two are the same. This is 60. This is also 60. Equilateral triangle. So this is 10. B.
Oh,
Okay.
what? Okay. Yeah.
Okay. What is the answer?
Same distance. No, same displacement, same displacement.
So your answer is what?
D.
Same displacement, no? Right? You can go from P to R, you can go from P to Q to R. So what we are looking is the final position, right? Which is C, correct? This one, right? Is the initial velocity, angle of projection. You want to find what is the maximum height above the ground that is reached by the ball.
Find the vertical component first, right?
Yeah, maximum height, we want to find vertical component, no?
12 sine, uh, 12 sine 50.
So
Okay.
taking hours as positive, what is given? Given is 12 sine 50, right? Work it out. Maximum height velocity is 0. Acceleration is downward, so it's minus 9.81. S equals to H. Then use V squared equals U squared plus 2AS. Right? H is that. Put in your value. Okay, out. C. Okay.
Yep.
Okay. How about this one?
Now what you mean? I think your stream. Next question is it? Question 7.
Question 7.
Your screen is frozen.
So what is your answer?
Speed.
Right? Weight equals to lift. Right? Lift is upwards. Weight of the camera dome is downwards. So it's equals to mv, basically Newton second law lah, equals to mg lah. Right? Yeah, we got 4 propellers. That's why it's times 4. And the mass of each propeller is 0.4. Right? Final velocity is 0. Initial velocity is u. And time is 1 second. Then the weight, right? That's the mass of the whole thing times 9.81. The answer is C. Can
Yeah.
screen sharing is paused. What is that meaning? Let me just check what went wrong. You can see everything, isn't it?
I can see, but it's frozen. It's frozen at question 6 right now.
Oh, no wonder it says screen sharing is. Yeah, what is happening? Can see it moving now? Yep. Can see now?
Yeah.
Don't know what went wrong just now. Frozen. Okay, how about this one? A box rests on the earth as shown. Newton's third law describes how forces of the same type act in pairs. One of the force of the pair is the weight W,
Boy.
which arrow represents the other force of this pair.
Boy.
Now,
Wait, what?
This is the weight is pulled by the earth, and then the box is pulled on the earth. That's why it's A, action and reaction forces.
Wait, teacher, but why the reaction diagram they always draw it on top?
This one is normal reaction, right?
Uh-huh. Normal reaction one, no?
Normal reaction doesn't come in. It is if basically it's action and reaction force. The earth pull on the box pull on the earth. That's what it is. So in the lower form, we in the SPM we teach you B equals to W, but actually is B doesn't come in. It's the earth that is causing it.
Oh, but that means all this while the diagram they draw about the normal reaction force is wrong.
Normal reaction force doesn't come in. It's the earth, the box, the reaction force is like that. The box is attracting the earth. That's W. And the earth is attracting the box. That's the reaction force. Okay?
Oh, yeah.
How about this one? A small box is held at the surface of liquid in oil in a container. The ball is released from rest and falls through the oil. The ball has a velocity of V. Viscous drag force acts on the ball. Which graph show the variation with V of F?
Donkey.
Say again.
Donkey.
It's basically like dropping in air. Right? So for low velocity, the drag is proportional to velocity. As our velocity increases, our drag force increases. And V reaches terminal velocity at high F. Right? So this start from zero. When you drop
Oh,
it,
yeah, yeah.
okay, when you drop it, zero velocity, velocity increases, force also increases. Then it reach terminal velocity. It cannot be this one. Right? Terminal velocity is around here. Okay, it is conservation of momentum. We got object of mass m with a speed u along a frictionless horizontal surface collide head-on with a stationary object. This is stationary, mass 4m. After collision, the object of mass m, this one, rebounds with a kinetic energy of its kinetic energy before collision. Right? 1/4 rebounds at. What's the speed of the object after the collision? You want to find the speed of this one after collision. What is your answer?
Yeah, give me a moment, I'm almost done.
Right? First, find the rebound speed. This one. Right? That's what is kinetic energy of this one. It's given by that formula. Right? And then you are told that the final kinetic energy after collision for this one is half mv squared. That this one bv is a quarter of here. So half and half m cancel off. So it becomes a half euro. Right? So that is the velocity here. That's the velocity here. So now we use conservation of momentum. Right? Initial momentum is this one. That one is zero because no momentum initially. Stationary. Then final momentum is 4m times w. Let w be the final velocity. And then final velocity is rebounds. So that's why it's negative sign there. 0.5 U times M. Cancel the M. Take this one across there. It's 1.5 U divided by 4. Answer is donkey. Can? Yep, yep. Any problem? Yep, yep, yep. Anything you don't understand? What happened now? You are muted.
Yeah, teacher, I lost connection.
Okay now.
Yeah, I lost connection.
Say again.
I lost connection just now. I got locked out of the call.
Okay. Can understand the answer?
Yes.
I think what I'll do is I will now go to paper two. Then during the break, give you time to try to catch up as many as possible. How about that? Or you prefer to carry on? Yep. Decide what you want me to do.
You, my connection is very bad.
Say again.
Continue on. But you asked whether should we continue with paper one or paper two, right?
I suggest now we go to paper two because you haven't done paper one yet. So during the break, you can try as much as possible all the paper one. How
Okay.
about that? Or you want to carry on?
Uh, I think can carry on.
Carry on, okay? You prefer that way? Okay. How about this one? All is written there already. That's the direction of the couple. This force is at 65 degrees to the horizontal. So what is the torque exerted on the steering wheel?
Uh, 5.4 newtons.
What's your answer?
Donkey.
Torque is force and perpendicular distance. Right? This is the perpendicular distance. So the normal force, perpendicular, take the perpendicular component. So 0.4 is the distance between them. Perpendicular force is 15 sine 65. Okay, good. How about this one? What change must be increased the outward force on the water tank?
A. A also can, right?
Using a longer rod and moving the pivot closer to the tank. Okay? Basically, it depends on this distance now. Right? Where the force is going to apply to here, depend on that distance there. The longer, the better. Okay, good. Too fast. Okay,
Yeah.
What's the answer for this one? These are all roughly the same or repeat question came up previously. Yep.
Um, I think it's donkey.
Now, you can draw on the diagram itself, right? The weight can transfer to here, then P can transfer to here. So it's this triangle. The answer is C, right? For balance, horizontal equilibrium, P equals to T sine theta, right? T sine theta. Vertical equilibrium, W equals to T cos theta. Okay,
Hmm.
this memory work.
Force per unit area.
That's all. Memory work, nothing much. A ball has a mass of 0.5 kilogram and a volume of 1.3 and 10 to the power minus 3 meter cube. The ball is floating in equilibrium on still water. The two forces act on the ball are the weight and the upthrust due to the water. Density of water is given. Percentage of volume of ball above the surface of water. Yep.
This one use pressure equal rho Vg, right?
Upthrust. First,
Upthrust
you have to find
rho Vg, right?
the volume that's inside the water. Right? So weight equals to upthrust. Upthrust, the formula you can find in the formula sheet. Right? That's the weight. It's the upthrust. Volume volume of ball below the water. Right? G and G can cancel off. And your V is M over G over rho. So M, that's your M. Right? Rho is water. Rho water. So find that volume. That's the volume below water. The volume above water, that's the volume of the ball. So you just subtract to get volume above water and then find the percentage of fraction, right? Times 100 will give you your percent. No? Okay, then answer
But this
C.
question is quite hard.
Oh, you need practice. You are still not ready yet. Okay, now anything still not clear? First, weight equals upthrust. Find the volume
Okay.
that is inside the water. Okay,
Volume. Yeah.
meant this understood already. This is a buggy. This is a kite. There's a tension pulling at an angle of 40 degrees horizontal. What's the work done by the tension force on the man on the buggy?
Oh. Uh.
Right? Work done is force times distance move in the direction of the force. So the force in the direction of the distant move Distant move is horizontal. So resolve this horizontally.
Phi 3.
B. Okay or not? Anything not
Oh yeah,
clear?
I got the answer, but it's
Careless.
3060. 3060.
Careless. Careless. Cannot afford to be careless.
3060 ah. I didn't know it's so the big difference. Okay.
Yeah, that's why I say cannot afford to be careless. Okay,
Yeah.
a ball is thrown vertically upwards on the surface of the earth. Which statement describes the energy of the ball as it rises through the air?
B. Boy, boy.
Why? Okay. Total energy of the ball is constant. Kinetic energy decreases. Potential energy increases.
Total energy is conserved.
No air resistance. Total energy, total mechanical energy is constant. Okay. It's kinetic
Yeah.
change potential. Okay. That's the extension. Height above the ground is your H above the ground here. Middle wire broke. The obey Hooke's law. The lamp is in equilibrium. The height of the lamp above the floor. Measure again. What is the difference between the two value of H? Yep.
So, but they didn't even give the weight of the lamp.
Say again.
They didn't even give the weight of the lamp.
They didn't give you. You just call it W. Lor. It will cancel off anyway. Just call it W. Lor.
Oh, you can solve. Okay.
Right? No need to panic. They didn't give you. Just give it. Let the weight be W. And then use your Hooke's law for the three wires. Right? The tension in each wire is W over 3. Then for Hooke's law, Kx, they already given you Hooke's law. So you give you the hint you use F equals to Kx. So that's your F. Kx. X is 0.4. So from here you can calculate your K. And after that, work with your two wires. So for two wires, right, the weight is shared between the two wires. So each of them is half W. Right? Extension now is X1. So X1 equals to half W, right? Divided by K. K is that, right? Divided by K, so it's upside down. Okay, so you just subtract 0.6 minus 0.4. That's the change in height. A can.
Yeah.
Okay, we will be finishing in 10 minutes time. So just in case you get cut off.
Gradient. Boy.
Okay. Ah,
Boy.
represent the work done to extend the spring. Work done, work done.
Oh, no. Sorry, sorry. It's not FOS, FS, so it should be area under graph.
A under graph A. Okay. Okay. What would this be? cannot see the sine curve. So what do you do to the time base and the y gain to see the sinusoidal waveform?
Oh, teacher, I forgot this one already.
You have to reduce the time base, so right? Answer is D. Your time base, increase the time base. So you make this one smaller, no? Then you increase
Teacher,
the
can you
y
tell me how it
gain.
works?
Say again.
Can you tell me how it works? I forgot about this part.
This one you increase the time base, you're making the scale bigger, that's all. That means instead of what 1 equals to 1 second, you make it 1 equals to 2 seconds. No? So
Increase the box size.
you want to make it into sinusoidal waveform, you can see the sinusoidal waveform. This one, the gain is too large. That's why you cannot see the sinusoidal is above there.
Oh, that's why you need to increase the box size.
No, no, increase the box size. The box cannot change, this is the CRO.
No, I mean decrease the wave size.
You want to make sure that you see the sinusoidal waveform. So you have to increase the gain. That means instead of
Oh,
1 cm equals 5 volt, 1 cm is 10 volt. No? So by increasing the gain, you are reducing the curve. No?
oh, okay.
Okay,
Yeah.
this one is straightforward. What do X and Y represent?
Amplitude and wavelength. See.
Amplitude and wavelength.
Yeah, see.
No, it's
What?
time. Time is should be period.
Hey, no. Oh,
You cannot afford to
ayo,
make this simple mistake. All
ayo.
these are
Sorry.
marks that you should be gaining, not losing. Okay,
Yeah.
okay. How about this one?
Oh, this one is the Doppler's effect.
Doppler effect.
So moving away from the observer is minus
Right?
or
Always
plus?
remember this picture. When it's moving to the observer, wavelength becomes smaller, so frequency becomes higher. And this one moving away from the observer, right? Larger wavelength, lower frequency. Yep.
Is it plus or minus? If it's moving towards the observer.
Use this picture to help you.
I mean in the
The
formula.
frequency, no need to use formula. This one,
Oh, no need.
no need to use formula.
Oh, yeah, okay.
Right? You want this component of velocity. This component of velocity that is moving towards the observer here, this observer, but it's moving straight that way. The answer is C. The component of speed. You look at this, the speed here is V cos theta. So as the angle, right, as the angle increases, the speed becomes smaller and smaller. Right? These cos are not sine. So C, frequency more, frequency more than F that decreases as the car moves from P towards Q. Can or not?
Yeah.
Okay. This memory work also.
Increasing wavelength.
What's your answer?
Uh,
Zero. X-ray is the smallest wavelength. All are visible. Right? Radar is microwave. Radar is microwave. And ND is radio wave. Okay. Going too fast. Okay now.
yeah.
Okay, next one.
Radio is the biggest one, right?
Radio, the longest wavelength. No?
Oh, yeah. Okay.
Before that is microwave. No? Yep. Got 2 more minutes. So in case you cut off, you use the time to catch up with what you have not done yet. No? Always remember that law of Malus or Malus law. Right? We're not interested in this one. We're interested in this part where it's polarized. This is the one polarized. This is I0. This is I1. Right? We're not interested in this angle, but this angle with the vertical. Right? So we are using this formula. I coming in. So in this case, we are using incident light is this I0 equals to Ka square. Transmitter light, right? I1 is transmitter light. This I0 here, right? Use Malus law, cos square theta, and equals to K A1 square, right? Divide. I0 cancel, K and K cancel, then square root it. Got that? Answer is C. Can
Yeah.
two progressive wave meet at a point. Which condition must be met for superposition or wave to occur? Superposition basically we are adding the sine wave lah. Okay. Right? It must be all the same type. Sound wave and sound wave.
Yeah, it's true.
Sound wave and light cannot.
Yeah.
Right? There's a note here. There's a note here. So this one is at frequency F. So what is the next frequency of turning wave to be formed on the string? This is 4 loops. You want 5 loops. What is the